In today's notes, we're going to be talking about quadrilaterals. Before we take a look at our quadrilaterals, we're going to start by breaking down some important symbols that we'll be using today with our drawings. The first symbol I want you to be familiar with is this small tick mark that will mark along the sides of our shapes. The tick mark means that those sides are equal, and the math vocabulary word we use for equal is congruent. So we're saying that the left side and the right side of this shape are congruent or equal. I can also tell that the top of the shape and the bottom side of the shape are also congruent because they marked them with the same number of congruent marks. If you see arrows on your shape instead of tick marks, this is telling you that those sides are parallel to each other. So remember, parallel lines never meet. And so what this shape is showing us is that the top and the bottom are parallel to each other, and the left and the right are also parallel to each other. So they marked them with the same number of arrows. The last symbol I want you to be familiar with is this small square that we'll draw in the corners of some of our shapes. That's going to be when our angle is 90 degrees. So remember, the angle is the measure of the corner of your shape, and when we have a 90-degree angle, we call this a right angle. So now that you know about these important symbols that we'll use in our drawings, let's go ahead and take a look at our quadrilaterals. So of course we know that a quadrilateral is a figure that has exactly 4 sides. So the first thing I want you to write is that a quadrilateral will always have 4 sides. And because it has 4 sides, it will also always have 4 angles. And when I take the sum of all of those angles, remember sum just means add. So when I add up all of the angles of my quadrilateral, I should always get 360 degrees. After we've listed our attributes and characteristics, we're just going to draw a couple quadrilaterals. So I'm going to start over on this dot paper on the right, and that's just to help you try to make straight lines as you're drawing your quadrilaterals. Just do your best or use a straight edge to help you. So if a quadrilateral is any 4-sided figure with 4 angles, I can think of lots of quadrilaterals. I could draw a square. So 3 by 3 by 3 by 3. It has 4 sides, so that means it's a quadrilateral. I could also draw a rectangle. I know a rectangle has 4 sides, so that's an example of a quadrilateral. I could also draw just a random 4-sided figure that doesn't have any attributes in common, really. Oops. Try that again. So this shape has 4 sides. Even though it's kind of funky looking, I can count them. 1, 2, 3, 4. So that is another example of a quadrilateral. You could also draw something that looks kind of like a kite. So we'll start with 2 diagonal lines at the top, and then 2 more diagonal lines to connect to the bottom. And so there's an example of a 4-sided kite. All right, so now let's take a look at another type of quadrilateral. This type of quadrilateral is called a trapezoid. A trapezoid is special because it's a quadrilateral, which means it has 4 sides. But when you are considered a trapezoid, that means you only have 1 pair of parallel sides. So remember, pair means 2. So that means we have 2 sides that are parallel and 2 sides that are not parallel. So now we're going to go ahead and draw some trapezoids. So the first trapezoid I want us to draw is going to have a top of 4 units, and then we'll draw 2 diagonal lines to create the bottom of our trapezoid. And the bottom of our trapezoid is going to be much bigger than the top. Even though the top and the bottom are not congruent, they are still parallel. These 2 lines will never meet. We could extend those 2 lines and they would never connect. Your trapezoid doesn't have to have left and right sides that are congruent, though. You could also have a trapezoid that looks like this. So go ahead to the bottom right corner of your dot paper, and we're going to draw a trapezoid that has a right angle in it. Okay, I'm going to go ahead and make my top a little bit shorter than the bottom again, and I'm going to extend the bottom a little bit more, actually. So here's another example of a trapezoid. I know this is a trapezoid, again, because it only has one pair of parallel sides. Which sides do you think are parallel to each other? The top and the bottom, or the left and the right? Hopefully you said the top and the bottom, because those lines will never meet. Okay, now that you know about a trapezoid, we're going to move on to our parallelograms. Parallelograms are very special types of quadrilaterals. We're going to talk about parallelograms first, and then we'll look at our last three shapes, which are all special types of parallelograms. So the first thing I want you to write down for your characteristics of parallelograms is this word parallel. That word parallel is in the word parallelogram, so I know that parallelograms have both pairs of opposite sides parallel. So that means two sides that are across from each other will be parallel, and the other two sides of your shape that are across from each other will also be parallel. Another special thing you want to know about those opposite sides is that the opposite sides, I'm going to abbreviate, are also congruent, which means that they are equal in length. So they're going to be congruent to each other. And the third thing I want you to write down, which we'll draw in our pictures, is that the diagonals of our shape, the diagonals are just the lines that we draw through the center of the shape, so connecting one angle to another angle across the shape. Those diagonals do something called bisect each other. And if you're not familiar with this word bisect, you've probably heard the beginning part of that word bi, like in the word bicycle. A bicycle has two wheels. That word bisect, means that the lines are going to cut each other in half. They're going to cut each other into two equal pieces. So if you can remember that bi means two, then hopefully you can remember that bisect means we're going to cut into two equal pieces. So now I'm going to go ahead and just draw some parallelograms. So a parallelogram can kind of look like a funky rectangle, almost like it's at a slant, like it's getting tilted over. So I'm going to draw the top, and then I'm going to draw the sides. And we want to make sure that the top and bottom are congruent and parallel. So to mark that the top and bottom are congruent, I draw one tick mark. To mark that the left and the right are congruent, I'm going to draw two of those congruent tick marks. And then to show that they are parallel, I can go ahead and draw one arrow to show that the top and bottom are parallel, and two arrows to show that the left and right are parallel to each other. Okay, so now let's talk about that third characteristic. We mentioned the diagonals. So if I were to draw a diagonal, that means I'm literally going to draw two lines connecting the corner to the other corner. So basically connecting the opposite angles. To be a parallelogram, that means that these lines are going to bisect each other. So they literally are going to cut each other in half. So if I cut in something in half, that means I've cut it into two equal pieces. So what we're saying is this left side of the line and the right side of the line are now congruent to each other. And I'm going to mark that with 3 tick marks. And we're also saying that this left side of the line is congruent to this half of the line. So that's what it means to bisect each other. So go ahead and finish drawing that while I show you some other parallelograms. So if a parallelogram is just a shape with opposite sides parallel and opposite sides congruent, well, I know that a rectangle has opposite sides parallel. The top and the bottom are parallel, and they're also congruent. I know that the left and the right sides of a rectangle are also parallel and congruent. So a rectangle is just a special type of parallelogram. Just adding my congruent marks for the left and right side and my arrow marks there. Another shape I know is a parallelogram is a rectangle. I'm sorry, not a rectangle, a square. So I'm going to draw a 4 by 4 unit square. And I know that in a square, all 4 sides are congruent to each other. So my opposite sides are still congruent, and my opposite sides of this square are also parallel. So those are parallel to each other, and the left and the right are also parallel to each other. So those are some examples of parallelograms you should have on your paper. And once you do that, we're going to go ahead and move on to the back of this page. So like we said before, rectangle is going to be an example of a parallelogram. I also know a rectangle is a quadrilateral because it has 4 sides. So the first thing I want you to write down about a rectangle is that both pairs of opposite sides are parallel, just like we saw before when we made a drawing of our rectangle. Both pairs of opposite, which just means that they are across from each other, opposite sides are parallel, which means they will never meet. They're going to kind of look like train tracks. We also know that those opposite sides, the top and bottom, and the left and right, are congruent. So we're going to write that those are congruent to each other as well. When I connect the corners of my rectangle and draw my diagonals, I will notice that the diagonals bisect each other. Remember that word bisect means we're going to cut into 2. Bi means 2, sect means intersect, like cut. So those diagonals are going to bisect each other. I'm going to abbreviate each other with an E/O. Okay, and those diagonals are also perpendicular to each other. So if you remember from the lines video we watched, perpendicular means that they meet at a 90-degree angle. So they're going to be right across from each other. And the last thing I want you to write down is that both pairs of opposite angles will be congruent. So the angles that are across from each other should be congruent, or they should be equal. Congruent. And if you want to, you can give yourself a reminder. Congruent just means equal. Okay, so now we can go ahead and actually draw out our rectangle, and we're going to use those symbols from page 1 to mark some of these characteristics we just mentioned. So I'm going to use the top left corner, or top right corner, excuse me, to draw a rectangle. And now let's go through and mark what we notice. So I noticed that the top and the bottom are definitely parallel to each other. I noticed that the top and the bottom are also the same length, which means that they are congruent. I noticed that the left and the right are parallel to each other. And I noticed that they are also the same length, which means they must be congruent. Let's go ahead and talk about the angles. I can tell by looking at my rectangle that all of these angles are actually 90 degrees. And so I know that my opposite angles are congruent because they have the same measure. The angles across from each other, this angle and this angle, are both 90 degrees. This angle and this angle are both 90 degrees. So they are all congruent to each other. And the last thing we talked about is our diagonals. So I'm going to draw some diagonals. So remember, our diagonals go across the rectangle, connecting corner to corner. And what we need to know is that the diagonals bisect each other. So my drawing's not perfect, but if it were, we would see that the left and right side of this line are the exact same length. And the left and right side of this line are the exact same length. They are cut perfectly in half. And it also tells us that those lines are perpendicular. So that means I should have a 90-degree angle when I connect those lines. So I'm going to go ahead and draw the center of my diagonals one more time since they didn't make that 90-degree angle. Well, that's a little bit better, I guess. And so we know that since these are perpendicular, these should be 90 degrees. So I can mark that those corners are 90 degrees. And I need to put back that the left and the right sides are congruent. Okay, go ahead and draw another rectangle of your own and then label it with the important symbols that we went over. So hopefully you drew something that had opposite sides congruent and parallel. Let's move on and talk about a rhombus. So our next shape, the rhombus, is also a parallelogram. When we draw it, our opposite sides will be parallel, and they will also be congruent. So we're going to go ahead and write one more time that both pairs of opposite sides are parallel, and both pairs of those opposite sides, the sides that are across from each other, are also going to be congruent. So opposite sides are parallel and congruent. The third thing, which is probably one of the most important things about a rhombus, is that all four sides are actually going to be equal to each other. All four sides are congruent. They all have the same length. Because all four sides have the same length, when we draw those diagonals, they are going to bisect each other. So again, that means they are going to cut each other in half, and I'm just abbreviating that word each other with E/O. The diagonals are also perpendicular, which means they will make 90-degree angles where they intersect. And I know this is a lot, but this is the last thing we need to make fit. The last thing I want you to write is that both pairs of opposite angles are congruent. So when I look at the angles across from each other, we should notice that they are the same size. Both pairs of opposite angles congruent. So if you need to pause the video to finish writing those characteristics, go ahead and do so, because now we're going to draw a rhombus. So here's my drawing of a rhombus. I'm going to go ahead and show you how I did this on the dot paper. Basically, I looked for one dot, and I noticed that I can go and connect 1, 2, 3 dots and make a diagonal line. And I can also go and connect 1, 2, 3 dots here and make a diagonal line. So I know right now these are congruent to each other. I also see that I have 3 dots here and 1, 2, 3 dots here. So now I know that all 4 sides of this rhombus are congruent, which means they are the same length. Notice the sides of this rhombus are not parallel. They all intersect each other. Another important thing about this rhombus is the angles. So let's take a look at these angles. So which angles are across from each other? We have this left angle and this right angle, which I can see are about the same size. They are congruent to each other. And I can see this top angle and this bottom angle are also the same size. So the angles across from each other are congruent. They are the same. Let's use the green rhombus to show our diagonals. So remember, our diagonals connect the angles that are across from each other. So I've got one diagonal here going from left to right, and one diagonal here going top to bottom. And this time, since my lines turned out to be straight, since I was able to follow those dots, I can see right where those lines intersect, we did in fact make 90-degree angles. I also noticed that our diagonals cut each other in half. They bisected each other. So I'm going to label on this red line connecting the top and bottom. This top half and this bottom half are congruent. This left chunk and this right chunk are also congruent to each other. So we can mark those. Go ahead and finish labeling your rhombus, and then we're going to move on to our squares. So what is a square? Well, a square is a very special quadrilateral because a square is a parallelogram, but it also has all the same attributes as a rectangle and a rhombus. It's almost like someone mashed together a rectangle and a rhombus to make a new shape. So in a square, we know that all 4 sides are going to be equal, but the first thing I want you to remind yourself is that both pairs of opposite sides are parallel. Which means that the sides across from each other are never going to meet. Opposite sides are parallel. I also know that all 4 sides are congruent, which means that they are equal to each other. So just like the rhombus where all four sides are equal. The thing that makes a square special or different from a rhombus, though, is that a square also has four right angles. So all four angles are 90 degrees. That was not always true with a rhombus. Because all four angles are 90 degrees, that means they're all the same. So all four of our angles are congruent. We can use our math vocabulary to describe that. Let's talk about the diagonals. So when I connect the corners of my shape of my square, I'm going to notice that my diagonals are congruent. The diagonals themselves are going to be the same length. Another thing I'll notice about my diagonals is that they are perpendicular bisectors. So that means when the two lines meet, the two diagonal lines, they are perpendicular. That means they are going to meet at a 90-degree angle. So we should be able to mark that where our two lines meet. The two diagonals are also bisecting each other, so we can call them perpendicular bisectors. Remember, bisect just means we're cutting into two equal pieces. So let's go ahead and draw a square. So I know a square has to have all four sides congruent. So I'm going to count to make sure that my sides are the same length. So let's start with a 4 by 4 square in the bottom right corner. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So here's my square. I'm going to mark that all four sides are congruent. And I'm going to mark that my opposite sides are parallel. So the top and the bottom are parallel. They will never touch. And the left and the right are parallel. They will never touch. I'm also going to go ahead and mark that all four angles are right angles. And because I don't want too many symbols on one shape, I don't want it to get too crowded, we're going to go ahead and draw another square so we can talk about the diagonals. So let's make a 5 by 5 square this time. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there you go, a 5 by 5 square. So I'm going to mark again that all four sides are congruent. And let's go ahead and draw our diagonals connecting corner to corner. So those diagonals are the exact same length. If I took out a measure or a ruler to measure the corners, oh, I'm sorry. If I took out a ruler to measure the lines that go from corner to corner, they would be exactly the same length. I also know that these lines were perpendicular to each other. When they meet in the middle, they made a 90-degree angle. And the last thing I notice about these lines is that they bisected each other. So I noticed that the left and right side of this green line are the exact same length, and the left and right side of this green line are exactly the same length. And since I know both of those lines are congruent to each other, all four of those sections are equal to each other. So they can all be marked with one tick mark. I guess I should mark them with two tick marks, sorry, since we marked the outside sides with one. All right, so that is all of your attributes of a square. Go ahead and pause this video and raise your hand if you have any questions.